Hello everyone, so today we are going to do Leetcode daily challenge maximum eraser value. So basically in this question we would be given with an array, and in that array we are required to find the sub-arrays, and those sub-arrays should be in that manner that it should be having unique elements, and we are required to return the maximum score. So in that sense, if we take the first example only, here if we see that there is 4 then 2, this is one sub-array. Then this 2, 4, 5, 6. This is one sub-array, right? So because of this fact only, we can see that this is the sub-array which has most elements, and moreover, the sum also is greater than the sub-array of 4, 2, right? So this would be our answer, and we are required to sum of that sub-array, which is 17, which we would be getting. So this is the thing which we are required to do here. Now before moving ahead, let us take the time constraints. So time, not only the time constraint but all other constraints. So the constraint here is 10 raised to the 5. That is, we are required to have order of n complexity solution. Means basically, if we can go with log n also, that also fine, but order of n would also work here. And then each number would be 10 raised to power 4. So when we would be adding them up, means at the worst case scenario, then also they would be in this particular only. Means they would be in the range of integers only. So we are required to return, we take our variables accordingly only. Now comes the next part, that how we are required to do this particular question. So for this question, like the first example which was being there, we are required to have a sub-array, unique element should be there, and maximum sum we are required to return. This is a constraint which is being given to us. So because of these facts only, we could either use two-pointer or sliding window approach in this particular question, because whatsoever array would be given to us, we could directly use the two-pointer approach, means left, right, or we can use even the same direction pointer also. That would also work, or we could use the sliding window approach. So this is the thing we are required to do in this question as per the question which says to us. Now, approach that I am using here, that time complexity is order of n, and the space complexity is order of k, and even the k could go till n, because there could be some sub-array which have all the unique elements, and in that case, our space complexity would be order of n. And why here I am using this term for means order of n space complexity, because the algorithm which I would be deriving, in that I am using, we can use either map for unordered map for easy lookup, or we can use array, but I would be using unordered map here. So that's why we are using some extra space. So the time complexity is order of n, and also the space complexity is order of n at worst case scenario. So now before moving ahead, let me explain you with the first example. Okay, so what we would be doing is the algorithm is somehow like this, that we will take the first element, right, and we will update the index. Where we are updating that index? We are updating that index in this unordered map. So we haven't seen this particular element, so we'll update here. Even if we would have seen, then also we would be updating. But the only thing is that if we would have seen, then we need to do some other steps also. But if we hadn't seen that particular element, then we'll update the index and update the sum and update the maximum sum. This is the thing which we would be doing. Then too, its index will update. We haven't seen it before, so we'll directly update the sum. This would be the current sum, and then maximum sum, which would be 6. That is the sum of both of them, 4 plus 2. at this particular portion. The thing is that here we encountered 4, which was earlier also. So now we are required to slide our window. So what we would be doing, we'll update our index. Yes, we have seen this particular. So we will enter this particular condition that yes, we have seen this particular. So now what we would be doing is, the previous index which was stored in our map, till then we will remove all the elements which we will encounter to get this 4. So here 4 was the first element only, right? So we'll directly remove this element and our window will start from here. So now this 4 is being entered into our sum also. This is entered and this was the one which we have removed from here. So our maximum sum makes 6 only. Now 5 is unique, 6 is unique, so they haven't been seen, so they would be updated. So this is the simplest example in which our algorithm would go ahead smoothly. And even this was being passed when I was using some other approach earlier. But when I had used my approach to this particular example, basically I got TLE for this particular example. So thus I was required to change my approach. So how I changed my approach was, let me show you. Now here the thing is that we are getting this 5, 0 index, it's not been seen before, sum and maximum updated. 2 again, we haven't seen that before, index updated, not seen before, sum updated, maximum sum updated, 1 same case. Now 2 is here, right? Now 2 has been already used earlier. So what we would be doing here would be, we'll remove both of these elements from our sum, and also we'll update the indices, and we'll also remove from our unordered map also both of these elements which are there. This is a thing which I updated in my algorithm. Else earlier what I was doing was, I was starting from this scratch again and again from my slided window and calculating the sum again and again from that starting window point to ending window point, and that was the thing that it was giving me TLE again and TLE, because sometimes it could be a scene that there could be huge number of iterations which could be there, and in that sense, then if we calculate sum again and again, then surely it will take much more time to calculate our overall solution. So rather than calculating the sum again and again, it's better, because we are using a sliding window, so we should properly utilize that particular fact. So what we are required to do, we'll remove all the elements which are there before the duplicate element, and even that duplicate element itself, because the purpose of sliding window here is to get all the unique elements, and thus rather than calculating that again and again, we should be utilizing the fact that we should remove the elements and add few elements rather than starting from the scratch. Starting from the scratch, what I meant to say was that I was again adding up these in my new window. Rather than this, what I would have done, that rather than adding all these elements again in this window, I should have kept this here only, have removed this particular and have added the new element. This is a thing which was required, and thus it stopped giving me TLE. So now let us come to this approach, that how this works. So yeah, now we are having this 2, right? So for adding up this particular new 2, what we would be doing is, now we will remove both of these elements. So now we have removed. So indices also would be removed from this unordered map, and from sum also this would be removed. So we have removed 2 and 5. Now we get our current sum as 3, but the maximum remain 8 only, because 3 is smaller than 8. Now 5. When 5 comes up, so now the thing is that our window was already slided, right? So because of our slided window, now what we are required to do is, Now what we are required to do is that our now our window is from this particular one, right? 1, 2, and now 5 is there. Now 5 comes up, but this particular 5 was already removed, right? So in our unordered map also, our 5 won't be there. So we haven't seen this, so we will directly add this, and now our current sum becomes again 8. So it will remain 8 only. Now 2. 2 is already there in this particular window also, right? And now again 2 comes up. So we'll again remove all these elements, right? So 1 would be removed and 2 would be removed, thus 5 would be current sum, but maximum sum is 8 only. Then we encountered 1. So as 1 and 2 was removed, then our window slided to 2, 5, a window slided from this red only. So 1 was already removed, so 1 is now not seen, right? So 1 would be directly added, and our new window is this one now, this particular greenish one, right? So now 2 is seen because 5, 2, 1 in this particular greenish window, 2 is already there. So we'll again remove this 5 and 2. So now our new window would be 1 and 2 only, this yellowish one. So we remove 2, added 2, subtracted 5. Now, when we encountered this particular 5, so this 1 and 2 was there, right? But 5 was not there, means we hadn't seen this 5. So we'll directly add this 5 to our answer, and we got 8. But at each moment already 8 was the maximum sum, right? So that's why our answer would be 8 only, and our window is this one, 1, 2, 5. The thing which is here is that as the maximum sum didn't, although the question is that we are required to just return the maximum sum, not that particular window from where we got the maximum sum, so it doesn't matter. So now as per the question, now we got our answer, that is 8, and we would be removing all the elements. Now the main points of this particular was that we are required to remove all the elements, till that duplicate element previous index. That is the thing which we are required to do, and in this context only we'll directly remove from unordered map, let me say it as UM, and also from the current sum. This is the thing which we are required to do at each step, and at every time what we would be doing, updating maximum sum. We'll update the maximum sum, we'll update the current sum with our present element, and we'll update the index which is there. This is the thing which we would be doing at every step of the sliding window approach. So now let me walk you through the code, that how we are required to do this, because now I have already tried on this particular, and I hope you would have got the rough idea that how we are required to do this. So this I have already taken example, that when I was encountering that TLE, so that's why. Now the thing is that we are taking this current sum, maximum sum in left, and this left we will be updating. Because of this only we are sliding our window, and this 3 unordered set which I have taken, there I was the map, but the thing is that we can use this by set also. There's no required to use a map. Then we would be we need to make some more code changes. So if we can do things with set also, then it's also alright. So we'll take each element, and then we'll take that while c.count num. Basically we hadn't seen that particular number, then we'll don't go into while loop. We'll do these operations only, means update our current sum with the num, then update our index, and then update the maximum sum. But if we encounter that particular element in our map also, means duplicate is encountered, So we have used while here because we don't know that it might be at the starting element only, or it could be element here also. The way here, when we encounter this particular 2, then we were required to remove both of these. So that's why we have used this while loop, that we'll directly subtract that 5 from the current sum, then subtract the 2 from the current sum. And see, the thing is that it will remove 5 also from the map, from that unordered set, and it will remove 2 also from unordered set because of this while loop. Until then, our left would be directly slided towards the right side. That is, our window size will change, our window would be directly changed. So that's the main thing which we are doing in this particular question. And also the thing is that this while loop is so small that we are not saying this particular solution as order of n square. At the worst case scenario also, this particular the thing is that this is for only that fact when we are encountering any duplicate, right? So at the worst case also, this can't go till that much extent that it could become an n square solution. So that's why this whole solution is order of n only, and the space complexity is because of the scene map only, scene unordered set only. So that's why space complexity is order of n. So this was all for this particular question. If you have any doubt, you could comment that down. Thank you.